All right, today we are doing 6.5 dividing polynomials. All right, our objectives are we're going to divide a polynomial by a monomial. Okay, divide polynomials using the long division algorithm, and we're going to divide a polynomial by a binomial of the form x minus a using synthetic division. Okay, so hopefully you remember these terms: polynomial, monomial, all that stuff. So that it's helpful. If not, we're going to go over it. So to divide a polynomial by a binomial, okay, that's what we're doing. So notice we have a plus b plus c. This is actually a trinomial because there's three components. There's an a separated by the plus sign, then there's the b separated by the plus sign, a c. So we have three. We're dividing by a monomial, which is one term. Okay, so when we have a polynomial divided by a binomial, it's the same thing as thinking of a polynomial as a plus b plus c and multiplying it by 1 over d, our monomial. And if we distribute that, right, then we would end up with a divided by d plus b divided by d plus c divided by d. Another way that you'll see me notate this, right, is we're going to do a divided by d, and I would circle that. And then we have to do b and divide it by d, and we have to do c divided by d. Either way, it gets me the same thing. Now, the difference is, in example 1, then, I will rewrite it out so that we have each of those. So we're dividing. This is a trinomial or a polynomial. We have one term, because there's our plus sign, a second term, there's our minus sign, a third term, and we're dividing it by a monomial, so just a single term. So the first thing we need to do is divide each term by the monomial. So we're going to take this first term. We've got 3x squared y cubed, and we're going to divide it by the monomial. So 3xyz. Then we have a plus sign, so I'm going to put plus. My next term in my polynomial is 9x to the fifth yz squared. Okay, over, and then we're writing that denominator in the denominator. I'm going to change this to, there we go, to make it look a little more cursive. Okay, so we're just dividing it by our monomial that was in the denominator. Then we have a minus sign, so we're going to have minus. We're going to write that third term in the numerator, so x to the fourth, yz to the fifth, divided by the monomial in the denominator, xy, 3xyz. Okay, and then we're going to simplify. Okay, so our 3's are going to cancel. I have x squared in the numerator and 1x in the denominator. So 1x is going to cancel, so that's going to leave me with x to the first. I have y cubed, a y down here, so one of my y's is going to cancel, so that's going to leave me with y squared. And my z I don't have. So this term simplified would be x y squared over z. Okay. So then here we have 9 divided by 3. So these both have a 3 in common. So 9 divided by 3 is 3. 3 divided by 3 is just 1. I have x to the fifth divided by x. Well, so one of my x's is going to cancel out. Y and y, both of those will cancel. Z squared and z, so one of my z's is going to cancel. So this would leave me with 3x to the fourth. I'm writing this too big, pardon me. Oh no, I don't have anything in my denominator, so I'm actually okay. I can keep writing it big. And my y's canceled, so I have z to the power of 1, so just z. And everything in my denominator canceled, so I don't have a denominator this time. Minus, okay, I don't have a number to cancel or anything with my 3, so my 3 is going to stay. X to the fourth and an x, so one of my x's is going to cancel, so that's going to become x to the third. Y and y, those will both cancel. z to the 5th divided by z, so one of my z's is going to cancel. So I'm going to have a denominator. This time I know because I have a 3 down there. I have x cubed and z to the 4th left. And this is my answer. Now, if this is a struggle to understand like why these things canceled, please come and talk to me. I'll show you really quickly. I'll simplify one of them out. Let's take this first one. We have 3x squared. So that means 3 times x, right? That's what 3x squared is. And then we have y cubed. So that means times y times y times y. I have 2 x's and I have 3 y's. And that's divided by 3 times 1x times 1y for the y times 1z. So when I'm looking at these to see what cancels, well, 3 divided by 3 is 1. X divided by x is just 1. Then I still have an x. 1 or y divided by y leaves me with y. And I don't have any more y's to cancel, and I don't have any z's in my numerator. So I'm left with x, y squared, and a z in my denominator. Again, if that doesn't quite make sense, come and see me. I'll be happy to talk with you about that or work it through, or try it out with the second and the third term and see what you get. See if you write it out like I wrote it out here, and make sure you get the simplified version that we have. Okay, then let's keep going. Okay, so to divide a polynomial by another polynomial. So this is when we have a polynomial divided by another polynomial. We're going to use the long division algorithm. So I hope that you rocked like 4th and 5th grade math and division. Because we're going to use that long division algorithm that you've used to divide large number. Now, the deal here is a remainder of 0, that's big, indicates that the divisor and the quotient are factors of the dividend. Because if we have a remainder, then that's not really a factor. Just like if we do 23 divided by 5. Well, 5's not really a factor, right? If we do 23 divided by 5, 5's not really a factor of 23. It doesn't go evenly. There's a remainder. The same thing applies in polynomials. If we have a remainder, because here we would have 4 remainder 3. If we have a remainder, then we did the division, but we have, it's not a factor. Okay, so it's the same thing with polynomials. I can only repeat that so many times, and you're probably like, we get it, Mrs. Talbert. All right, so in order to do example 2, okay, it says divide x cubed plus 4x squared plus x minus 6 by, we're dividing by, x squared plus x minus 2. So we're going to rewrite the problem using the long division format. Be sure the terms are in descending order. Okay, what that means is we have an x cubed, then we have an x squared, then we have an x to the power of 1. We don't write it. And then we have a number with no x. We have our constant. So this is in descending order. Okay, so we can write this out and get started. So we're going to have x cubed plus 4x squared plus x minus 6 divided by x squared plus x minus 2. Yeah, we're doing long division today in Algebra 2. So we're going to divide the first term of the dividend, x cubed, by the first term of the divisor. So maybe I'll circle that. And write the result in the quotient. All right, so here's the deal. What's x cubed divided by x squared? So essentially, the other thing is, what do we need to multiply by x squared by to get x cubed? Well, I would multiply by x. I hope you can see that yellow. It's showing up really vibrantly and well for me, so I hope you can see it. Next step, we're going to multiply That is a typo. The entire divisor by the quotient, aligning the product under the dividend. So we're just going to do x squared times x. Well, that's x cubed. Plus x times x. Well, that's plus x squared. Notice I'm lining it up, or aligning them. Negative 2 times x is negative 2x. Awesome. Then we're going to subtract and bring down the next term to obtain a new dividend. So we're going to take this whole thing and we're going to subtract it. X cubed minus x cubed is 0. Those cancel. 4x squared minus x squared is going to leave me with a positive 3x squared. Okay, x minus negative 2x, wait a minute, that's going to make this plus a positive, right? So x plus 2x is going to give me a positive 3x. All right. Notice it said to subtract and bring down the next term. So that's what I got to do now. I got to bring down my minus 6, just like in long division. Then I'm going to repeat the previous 3 steps until I'm finished. All right, so that means x squared, what am I going to take? X squared, and I've got 3x squared. So what's 3x squared divided by x squared? Or what do I need to multiply by x squared by to get the 3x squared? I need to multiply by a positive 3. And then I'm going to multiply this positive 3 by each term here in my divisor. So 3 times x squared is 3x squared. 3 times x is 3x. And I'm aligning my terms. 3 times negative 2 is negative 6. Okay, remember we're subtracting these. That's the next thing. All right, so 3x squared minus 3x squared, that cancels and leaves me with no x squareds. 3x minus 3x, oh, that cancels and leave me with no x's. Yay! Negative 6 minus negative 6. Okay, we got to think that's going to be plus a positive. So 6 plus 6, sorry, negative 6 plus 6 is 0. Hey, hey. So I am done and I have no remainders. So think back to what this said, right? No remainder, or actually there's even a note here. A remainder of 0 indicates that the divisor and the quotient are factors of the dividend. So we could have arrows to both of those. So 1, I've got to think, okay, time out. What is my answer? I just did this division. My answer is right up here. So x cubed plus 4x squared plus x minus 6 divided by x squared plus x minus 2 equals x plus 3. Woohoo! It means I have a 0, so it means that this is indeed a factor. There's no remainder. It's a perfect factor. That's awesome. The other thing that this means, which is kind of cool, it means that if we take our x plus 3 and we multiply it by what we used as our divisor, this x squared plus x minus 2, it's going to equal the polynomial that we started with. It's going to equal that x cubed plus 4x squared plus x minus 6. So that's what this means, right? The reverse of division is multiplication. We've been doing these math problems like this, right? Distributing, foiling, all those things. Now we're learning the division part, how to work them backwards. Whew, it's a lot, but it's kind of cool. Just a little bit though. All right, let's move to example 3. Okay, example 3 says determine whether x minus 2 is a factor. Okay, so we're looking to see if it's a factor of 3x cubed minus 8x squared plus 14. Okay, so in order to be a factor, Remember, we're going to divide, and it has to have no remainder. That was the note up there. We divide it, and no remainder, then it's a factor. Okay, so in our little notes here, it says insert 0x as a placeholder in the dividend. Oh, we're still following the same steps as in example 2, but if we look, right, we had to look for that descending order. We have x cubed, x squared, no x. So we have to insert a 0x. So we have our descending order, and then we have our 14 or our constant, which is fine. But we have to insert that 0x as a placeholder. So we're going to have 3x cubed minus 8x squared plus 0x plus 14, excuse me, divided by x minus 2. All right. And then we're going to divide using the divide, multiply, subtract steps of the long division algorithm. Okay. So we're looking at x and 3x cubed. So I need to multiply by 3x squared so I can get 3x cubed. So x times 3x squared is going to be 3x cubed. Negative 2 times 3x squared is going to be negative 6x squared. I'm subtracting these. So 3x cubed minus 3x cubed cancels. Negative 8x squared minus negative 6x squared, well, that's the same thing as plus a positive. So negative 8 plus 6 is going to give us negative 2x squared. And we bring down our 0x. All right, now let me switch up our colors here. So now we're looking at our x and trying to get this negative 2x squared. What am I going to multiply by? X times negative 2, and I need x times x to get x squared. So negative 2x times x would give me negative 2x squared. Negative 2x times negative 2 would give me a positive 4x. And I've got to subtract these. So negative 2 minus negative 2, remember that's going to make this plus a positive then. So negative 2x squared plus 2x squared, that cancels. 0 minus 4x is going to give me negative 4x. I bring down my 14. Okay, so now I'm trying to put, what do I need to multiply x by to get negative 4x? I'm going to have to change my colors, actually. So what am I going to multiply x by to get negative 4x? So x times negative 4 would get me negative 4x. So negative 4 times x is negative 4x. Negative 4 times negative 2 is a positive 8. Remember, I'm subtracting these. Negative 4 minus negative 4x, or sorry, negative 4x minus negative 4x, that's going to be plus a positive. So negative 4x plus 4x cancels. 14 minus a positive 8, so 14 minus 8 leaves me with 6. I don't have anything else to bring down. So this is a remainder. Okay, so I'm going to have 3x squared minus 2x minus 4, remainder 6. So is this a factor? Is x minus 2 a factor? No. Okay. No. X minus 2 is not a factor. Because why? Because it has a remainder. Or because there is a remainder. However you want to look at it. But that's simply it. If there's a remainder, there is It is not a factor. It doesn't go nice and neat. All right, then we've got synthetic division. Okay, synthetic division is actually a simpler algorithm that can be used to divide a polynomial by a binomial of the form x minus a. Okay, so really awesome to use synthetic division. How However, so here's the thing, and we'll compare these two. Synthetic division is the same process as long division, except it eliminates the repeated writing of the variables and uses just a from the x minus a. So we will walk through, like this is the problem we just did. We're going to walk through it in synthetic division so you can see how it is simpler. Like it might take up a little bit more space, but it's not as clustered and full of space either. It seems more open and clean to follow. Okay, so if we look at the synthetic division, again, compared to the long division we just did, we still need to insert the 0x. We have to add a 0x. You'll notice it's right here. Okay, and then we can continue going. So notice that we've taken the constant or the term in front of each variable. So we've got the 3, the -8, the 0 that we inserted, and a positive 14. Okay, so we're setting it up in the same order that they are in that descending order. And then we're only taking the 2 to divide by from this form x minus 2. Since we have x minus a is the form, we're just taking the a value. So our 2 is our a value. Okay, so we bring our 3 down below the line. And so we say, okay, well, what is 2 times 3? Well, 2 times 3 is 6. So we write that number here, which is what just happened. Okay, so -8 plus 6 leaves me with a -2. So now I'm going to say, well, what's -2 or 2 times -2? Well, it's -4, so it's going to go here, which is what I have here. So then I have 0 plus -4 is -4. All right, so then I'm going to say, well, what's 2 times -4? That's -8. So that number goes here. And then 14 plus -8 is a positive 6. Now the other thing, which we didn't have to talk about previously, is what do these numbers mean? Here, the 3, the -2, the -4, the 6. Okay, so if you look, we started with x cubed. Okay, they're in descending order. So the next one in descending order after x cubed would be x squared. So that's why this is 3x squared. So we just start with the next term in order, because it's obviously not going to be cubed, it's going to be the one below it. So 3x squared minus 2 would be an x, minus 4, I would have a constant, right? All my x's, I've used all of them. So if I have this number left, this 6, it's a remainder. Okay, so you get the exact same answer that you got with the long division, but it's a little bit quicker to use synthetic division. All right, so let's do this first one. I think I can squeeze it on here. Okay, so we're going to use synthetic division to divide. So these instructions are actually specifically to that problem over there, so I apologize a little bit. But we're going to list the coefficients of the dividend in descending degree, like always, including the 0 for any missing terms. Okay, so we have x squared and x and then our constant, so no missing terms. So our coefficients here would be a 1. Then we'd have a -4, so I should circle in front of there. So -4 and then a positive 2. All right, again, we're going to place, this is our divisor. The form is x minus a, so here our a equals 2. So we're going to divide by 2. All right, we are going to bring down our 1 and get started. Okay, so this is kind of just our starting setup. So maybe I'll change colors to show the rest of it. Okay, so we're going to do 2 times 1 is 2. We put that number there. Negative 4 plus 2 is a negative 2. Then we're going to do 2 times negative 2 is negative 4. So 2 plus negative 4 is negative 2. All right, so that doesn't mean anything. We don't know if we have a remainder or anything yet until we put it in that form. We look back and we say, okay, we had an x to the power of 2, so our answer is going to be an x, a 1x. Then we have minus 2, which is our constant, which means this is our remainder. Okay, so x minus 2, remainder of negative 2. So this, we know, is not a factor because it has that remainder. Right? It's the remainder that makes it not a factor. Okay, let's look at b. I think we can get it to fit too. Okay, so let's check our terms. We've got a cubed, a squared, a, and then a constant. So we're good. We don't have to insert any zeros. Okay, if we check the next part, it's supposed to be our question here, or what we're dividing by, is supposed to be in this form x minus a. In this case, we have a as our x, so it would be a minus, that's going to be confusing if I write it as a minus a. So we'll just go back and write it as x minus a is that form. So if we have a plus a positive 2, that means our a equals a negative 2 here. So we're dividing by negative 2. Okay, so let's get it set up. We're taking the coefficients. So we have 5, positive 4, negative 7, and a positive 9 divided by our a value, which is negative 2. Okay, we're going to bring the 5 down, and then we can get started. So negative 2 times 5 is negative 10. 4 plus negative 10 is negative 6. I had that on my mind. Negative 2 times negative 6 is a positive 12. So that goes there. Negative 7 plus 12 leaves me with a positive 5. Negative 2 times 5 is negative 10. 9 plus negative 10 is negative 1. So the math, right, like it's much more succinct to do the division this way. And then the next step is always the most important, like what do our answers, what do these numbers mean? So we started with a cubed, so this first term is going to be a squared. So we've got 5a squared minus 6a plus a 5, and I still have another number after my constant, so that means I have remainder negative 1. This is the answer to my division, but a plus 2 is not a factor either because we have a remainder. So a plus 2, maybe I should write that, is not a factor. Just like here, x minus 2 is not a factor. All right, let's try one more of these. Example 5. Okay, let's use synthetic division to divide x cubed minus 7x plus 6 by x plus 3. Okay, so let's check. We've got x cubed and then x, so we don't have an x squared. We need to insert a 0 x squared. Okay, so that would be x cubed plus 0 x squared minus 7x plus 6 that we're dividing by x plus 3. Okay, so then if we look at our divisor here, what's our a value going to be? All right, good. It would be negative 3, so we need to use that. Then we can set up our synthetic division. So in our synthetic division, we're going to bring the coefficients. So we have a 1, a 0, negative 7, and 6 that we're dividing by our a value of -3. All right, so first thing, we bring down that first number, and then we start doing our multiplication. So -3 times 1 is -3. 0 plus -3 is -3. -3 times -3 is a positive 9. That goes there. -7 plus 9 is a positive 2. Then we've got -3 times 2 is -6. 6 minus 6 is 0. Now, this should be ideal. If you see a 0, you should probably be like, ooh, I'm probably not going to have a remainder now that you've done it a few times. But we need to put it in that correct notation. If we started with an x to the power of 3, we know this is going to be x to the power of 2. So we're going to have 1 x to the power of 2 minus 3x plus 2. So I have my constant and I don't have any more numbers. So this is my answer, okay? Which means that x to the x plus 3, that quantity, is a factor because there is no remainder. Okay, so we're finally there. Now, if you remember, this also means, right? This also means, since there's no remainder, if we take this quantity, x plus 3, and we multiply it by the answer that we got, the x squared minus 3x plus 2, then it's going to equal the polynomial that we started with for our division. So it's going to equal that x cubed minus 7x plus 6. Okay, because we just found a factor. We divided a polynomial by another, or by a binomial, to get the answer, okay, or another polynomial. So a binomial times a polynomial equals a polynomial. All right, that is it for dividing polynomials. And so if you have some questions in class tomorrow, that'll be perfectly fine. But we will go through them and get it going.